Hi class, today we're going to be talking about properties of logarithms. And I have here the basic rule that we learned when we first learned about logarithms, is that y is equal to log base a of x if and only if x is equal to a to the y power. And we've learned in previous classes that the base of the exponent and the base of the logarithm are the same, a, and it has to be positive and not equal to 1, and that the domain of the logarithm has to be, the argument has to be positive. So I have those statements written over here. Now I'm going to be writing some properties of logarithms, and for all of them we want to keep in mind that the bases that we refer to have to be positive and not equal to 1, as well as any arguments that I'm saying, we're going to assume that they're positive when I write them in here. Some of our properties come just from learning, from writing statements in exponential form and then rewriting them in logarithmic form. For example, if I said a to the power of 0, well, anything to the power of 0 is equal to 1. And so if I take this statement and rewrite it, I'm going to get log base a of 1 is equal to 0. And so these statements are equivalent statements. Likewise, if I asked you what is a to the power of 1, well, that's easy. That's a. And so I'm going to rewrite this as a logarithm again. We are going to get log base a of a is equal to 1. This next one is slightly confusing because the pieces look the same. But if a to the r is, of course, equal to a to the r, I'm going to rewrite this as a logarithm using the blue a as the base. The argument is going to be a to the r. And the exponent becomes the r after the fact. And so you can see that log base a of a to the r becomes r, and it just gets simplified. And this should make sense to you because basically what we're doing in the statement is the input is an exponential, and that's going to be in a logarithmic function, and those two functions are inverses of each other. So when you compose them like this, our input r is our output r as well, which is exactly what we think it should be. Likewise, if I have a statement log base a of m is equal to log base a of m, that makes sense, but let's take this and rewrite it as an exponential statement. The base of my logarithm is a, so that's going to be the base of my exponent. The power is going to be log base a of m, and the argument is the answer. So we have a to the power of log base a of m is equal to m, and once again we're looking at this as the composition of logarithms with exponentials, and my input of m becomes my output of m. And my input of m becomes my output of m when I compose those two functions together. These are the first 4 properties of logarithms. I'm going to write a few more. And this one that I'm going to write just means that when you have log of base a, m to the r power, that power can come out as a coefficient, and then you have r times log base a of m. There's no good analog for this in the exponential form. So this is just one that you have to remember, is that the power, the m to the power of r, that power of r can come down as a coefficient, and that's a very helpful rule. We also have log base a of an argument that has factors m times n can be separated into 2 separate log statements. This would be log base a of m plus log base a of n. Now keep in mind that when you do this, you have multiplication inside the argument of one single log, but you have addition of 2 separate log functions. And since the multiplication turns into addition, we have division, which will turn into subtraction. So these are the properties that we're going to be using as we want to solve problems. And before we get into solving any problems with them, we just have to practice to make sure that we understand the properties. So this section will be all about practicing these rules and learning how to write and rewrite different logarithms and different exponential problems so that we can have them in simplified format. Once you get those skills down in this section, then we can move on to the next section and solve questions using these properties to help us. The first questions ask us to use these properties to find the exact value of each expression. Keep in mind that we are not solving, we don't have any variables, and we are just simplifying using the algebraic rules and the properties that we were given. So for this first one, we see that we have log base 6 of 9 plus log base 6 of 4. You're going to take that and turn that into one log with the 9 times the 4 inside one argument. And you can simplify that. 9 times 4 is 36. And let's just take that and write that with a base of 6. So that would be 6 squared. And one of the properties we learned is that if you have a base of the log and the base of an exponent in the argument, then you can just simplify that. Those cancel out and you just get 2. The next question we have is 5 to the power of log base 5 of 6 minus log base 5 of 7. So the first thing we're going to do is simplify that exponent to be one simple log. So that's going to be log base 5 of 6 divided by 7. And when you have 5 to the power of log base 5, those cancel out and the argument just becomes our final answer. So that simplifies to become 6/7. There's one more property of logarithms that we did not discuss on that first page, and it's the change of base formula. And basically, if I have a log base A, I can change it to be any other base I want. I can change it to any other appropriate value, meaning any positive value. And so I'm just going to use B for my new base, and I'm going to say that's log base B of M divided by log base B of A. Now this is different from the property that we had before. The property we had before with division had division within one argument, which turned into addition outside the logarithms. This is an actual logarithm divided by another logarithm, so two separate logarithms. Let's see how this one works. What I have here are two separate logs being multiplied, which we don't have any rule for that. But I noticed that some of the values in here are related to each other. So I'm going to rewrite this, and I'm just choosing to rewrite it with log base E, which we will write as ln. So that's going to be ln of 8 over ln of 3. And we're going to multiply that by ln of 9 over ln of 8. And notice that now we have two statements that can reduce. So I'm going to rewrite this as ln of 9 over ln of 3. And notice that I think I want to write them back into log base 3. So I'm going to say log base 3 of 9. That's using the change of base formula the other direction, combining these into one statement, and then that can become log base 3 of 3 squared, which we saw before. When you have the base of the log matching the base of the exponent inside the argument, you can simplify that and just have the exponent be your answer. And so that whole statement simplifies down to 2. Now we're going to suppose that ln of 2 is A and ln of 3 is B. And we're going to rewrite these logarithms in terms of A and B, meaning I'm going to try to rewrite them in terms of ln of 2 and in terms of ln of 3, using the properties that we were given. So the first one is ln of 0.5, which you should know is the same thing as 1/2. And 1/2 is the same thing as 2 to the power of -1. And we have the rule where the exponent can come out to the front. So I'm going to write that as -1 times ln of 2. And now I'm going to replace ln of 2 with a, so that just becomes -a. And so we've taken ln of 0.5 and written it in terms of a and b. Let's do that again with question number 5. We want to rewrite this as ln of 2 over 3 to the power of 1/4. And let's take that power out to the front. That's going to be 1/4 times ln of 2/3. And I want to rewrite that as 1/4 times ln of 2 minus ln of 3. Because division inside my logarithm turns into subtraction outside the logarithm. And then I'm just going to replace the ln of 2 with a and the ln of 3 with b. And so here we go. We've used some algebraic properties to rewrite this logarithm in terms of a and b. The next 3 questions ask us to write as a sum or difference of logarithms. So anything that's a product inside our arguments is going to become addition of logarithms. And we want to also express any powers as factors, meaning as the leading coefficients. So for this one, we have ln of a product in here, x times e to the x. We're going to separate that product into two separate logarithms. That's ln of x plus ln of e to the x. And then we're going to rewrite that one time, bringing that power of x down as the coefficient of ln of e. And then we know that ln of e should be 1, so that's going to cancel out. So we just have ln of x plus x. And take care not to combine the x and the x here, because one of those is inside the logarithm and one of them is not. This ln of e turned into a 1. This next question, it does say that x has to be greater than 0 on the question, and that's just for the domain. It's stating it for you already without asking you to provide it. We're going to take this, and it's a product, so again we're going to say ln of x plus ln of the square root of 1 plus x squared. And I want to take that second one and rewrite it. Instead of a radical, I want to put 1 plus x squared to the power of 1/2. And we're going to take that power and we're going to bring it out to the front. And then we're going to have ln of 1 plus x squared. Now you might be tempted at this moment to go ahead and split up that ln of 1 plus x squared into further groups, but we can't, because you can only split them up when they're factors. So when they're being multiplied, like in the first question, x times e to the x, and when multiplied in the beginning of this question when it was x times the square root of 1 plus x squared. But inside my second logarithm right now, I have 1 plus x squared, and you can't split that up. If we could factor it, we could split it up more, but that's prime, so we can't factor it, and we can't break up when there's addition inside the logarithm argument. So that's as simplified as it can get. This last question has a lot of parts to it, so in the interest of saving space and time, I'm going to do several steps at once. I'll talk my way through it. I'm going to bring down the power as the coefficient, and I'm going to multiply that by several terms that are going to be added, so I need to use parentheses or brackets to hold all of my pieces together. I'm going to have ln of the numerator, and then I'm going to subtract ln of my denominator, which can be factored to x plus 1 times x minus 1. And then I have to close my larger brackets. And then I have to distribute that, I have to factor again that second one. let's write this as 2 ln of x minus 4. And then we're going to say minus, and this is going to be ln of x plus 1 plus ln of x minus 1. And then I have to close my larger bracket. Let's simplify this one more time. I'm going to get 2/3 times 2 ln of x minus 4 minus ln of x plus 1 minus ln of x minus 1. And we have to enclose the whole thing in brackets because that 2/3 gets multiplied by everything. Notice that the x squared minus 1 in the denominator turned into x plus 1 and x minus 1, and both of those coefficients turned into minus. So if you have multiple terms in the denominator, even though they're being multiplied, you have to distribute that minus so that all of them are minus. Anything in the denominator turns into a minus sign. The last 3 questions we did, another way of writing those instructions would be to say write in expanded form. Notice how we started off with something nice and neat, and then we're expanding it to be each individual term. Conversely, for questions 9, 10, and 11, we're going to be writing them as a single logarithm. In other words, the instructions might say condense. In order to condense them into a single logarithm, they must all have the same base, so that's something you should be checking. Both of these are base 2. We have log base 2. So since they're being added, we're going to multiply their arguments within the same logarithm. And so we're going to get something like this, and we can simplify that. And there you go. We have log base 2 of 1 over x cubed. When I'm looking at the next question, I notice that the first log argument can be factored. I notice that there's a coefficient as well for the log that I want to bring in as a power. And I notice that they're both log base 10, so I can combine these. Let's do that. So I'm going to write log of x plus 2 times x plus 1, and then minus log of x plus 1 squared. And since it's minus, it turns into division, so I'm going to write log of x plus 2 times x plus 1 over x plus 1 squared. And we can reduce that. I notice that that means we have an x plus 1 that cancels out. So I have x plus 2 over x plus 1. And there's nothing I can do about that now, so that's as condensed as I can make it. I've written them as log of x plus 2 over x plus 1. This last one, I'm going to do all of the steps at once. So let's see if you can follow along. Notice that we have 3 terms, and we have to decide where to put them because some of those terms have positive coefficients, and some of those terms have negative coefficients. Anything with a positive coefficient will go in the numerator, anything with a negative coefficient will go in the denominator, and then any of those coefficients become powers at the same time. Once again, we notice that all of these are log base 5, so I'll write that as log base 5. And then I'm going to put 3x plus 1 cubed in the numerator. The next term I'm going to put in the denominator, it's going to be 2x minus 1 to the power of 2. I'm putting it in the denominator because it had a coefficient of negative 2. The negative puts in the denominator, the 2 becomes the exponent. The last one is x, and because it has a coefficient of negative 1, an invisible 1, I'm going to put it here, x to the power of 1 in my denominator. And so let's just keep our entire fraction together. This is in condensed form. The last 2 questions ask us to evaluate each logarithm to 3 decimal places, so you will need to use your calculator to do that. However, your calculator only has 2 buttons, the log button and the ln button. The log button is log base 10, and the ln button is log base e, but the question is asking us about log base 1/2. How are we going to do that? Well, we're going to take this and we're going to rewrite it using the change of base formula. So I'm going to take this and say ln of 15 over ln of 1/2. Now, you can type this into your calculator now. You could have also chosen to rewrite it with log base 10. So you could have written log of 15 over log of 1/2. And both of those will give you the same answer. Go ahead and use your calculator. And my calculator gives me the value of negative 3.9068. And we want to round that to the correct 3 decimal places. So I'm going to say negative 3.907. Now, if you're not getting the same answer as me, more than likely it's just a matter of parentheses and formatting. So you want to make sure that every time you type in the log button, it will give you a parentheses, and after you type in your argument, you have to close your parentheses before you go on with the rest of the problem. But that's typically it. And we're going to skip the graphing problem in the notes. We're just going to number 12. Thank you. Practice these properties so that you can do good when you're solving equations in the next section.